Hi everyone, this is Mr. Cervone. Welcome to my channel. In today's lesson, we will be learning how to solve systems of linear equations algebraically. Here we have an example. Solve the following system of linear equations. 5x minus 2y is equal to 1 and x plus 3y is equal to 7. Now what does it mean when we say solve the system of linear equations? What this means is namely that when you graph both functions, we're looking for the point where they intersect. More specifically, for the point or the coordinates at the point where they intersect. It's basically this point over here. Obviously, you can also do it graphically, but in today's lesson, we're going to learn a method on how to solve this algebraically. So there are two ways to solve a system of equations algebraically. So let's discuss the first method first, or the first way to do this. It's called the substitution method. So for the substitution method, the goal here is to take one of the equations, isolate one of the variable, and substitute it into the other equation. For example, if we take the second equation, that is an easy one to pick first because we have x by itself without any other coefficient in front of the x. So in this case, we can solve for x and write the following. X is equal to 7 minus 3y. Okay, so now we take the first equation and we have 5x minus 2 is equal to 1. So let me write this in. So here we have 5x minus 2y is equal to 1. But we know that the entire x value could be substituted for 7 minus 3y. So we can write here that 5 times 7 minus 3y and then minus 2y is equal to 1. Notice that now we can solve this equation because we have one equation with only one variable, namely the y value, okay? Okay, so let's solve for y here. So if we multiply this out and get rid of the parentheses, we end up with 35 minus 15y and then minus 2y is equal to 1. And then we end up with 35 minus 17y is equal to 1. And what we can do now is subtract 35 on both sides. So we have negative 17y is equal to negative 34. Okay, so if we divide negative 17 on both sides, then we end up with a y value of equal to 2. Okay, so we were able to find the y value. Now, how do we find the x value? Well, we can just simply go ahead and substitute it back into the equation for which we isolated the variable for. So in this case, all we need to do is say x is equal to 7 minus 3 times 2. Okay, so here we have x minus 7 minus 6, and therefore x is equal to 1. Okay, so that means that here the answer for this problem here, or the solution for the system of equation, is 1, 2. Okay? Now you can always double check if this makes sense using various ways to do it. For example, if you go back to the original equation, is it true that when x is 1 and y is 2, that these two equations are true? And you can try this out, right? And say, okay, 5 times 1 minus 2 times 2 is equal to 1. Is that true? Well, that's 5 minus 4 is 1, so it actually works. For the second part, we have, or the second equation, 1 plus 3 times 2 is 7. And then we have 1 plus 6 is 7, so that also works. And we can see that it definitely works. Earlier, we also looked at the graph, and we saw that that is the point of intersection. So here we have 1, and here we have 2. So it is actually a plausible answer, right? And we're pretty sure that the solution to the system of equations is 1, 2. So let me now introduce to you a second method of solving a system of equations algebraically. and that is called the elimination method. Now, with the elimination method here, the goal is to somehow add or subtract these equations such that you eliminate one of the variables. So let's say we want to eliminate the x variable. So this is how you proceed. First, you rewrite the first equation as 5x minus 2y is equal to 1. Now, if we want to eliminate the x variable, they both have to have the same coefficient of 5. Or the second equation can have a coefficient of -5. So what we can do here is multiply the entire equation by -5. And notice that you can multiply any equation by any number other than 0, and the equation will always be true. So for example, here if we multiply by -5, we have -5x, then we have minus 15y is equal to -35, okay? Now once you do this, you make a line, and our goal is to add both of these equations, okay? And if we add 5x and -5x, notice that this cancels. So we have 0 and we have just eliminated the x variable. Now when you add -2y and -15y, you have -17y equals to, and now you have 1 minus 35 is -34. Does this look familiar? Yes, we had the same exact equation over here where we use the substitution method. So now you solve for it and you end up with y is equal to 2. Once you have the y value, now we can back substitute into one of the original equations and figure out what the x value is. So let's say we want to pick the second equation here like this. So here we write x plus 3 times, and now instead of y, we are going to substitute the 2 for the y, and that is equal to 7, okay? So that means that x must be equal to 1 for this to be true. And there you go, we found the answer, which is 1, 2, and that's the coordinate point where both equations intersect. And that is the solution of the system of equations. Now, a third method is using the graphing calculator, okay? So for the graphing calculator method, you must change the equation to slope-intercept form, as shown. So the first equation corresponds to y equals to 5 half x minus 1 half, and the second equation corresponds to y is equal to -x over 3 plus 7 thirds, and both are now in slope-intercept form and ready to be input into the graphing calculator. So once you input these equations in slope-intercept form into the graphing calculator in the y editor, all you need to do is click the button where it says graph and wait for the graph to appear. Now notice that not both equations are completely shown here. Specifically, the intersection point is not shown. So how do you fix this problem? So what you can do here is click on Window, and now you can specify what the range should be for the x and y-axis, okay? So for example, let's say we take a minimum value of -10 and go all the way to +10 on the x, okay? This means that the XSCL means that we're going up by every 1 unit on the x-axis. And let's say on the y-axis, we'll do the same thing, okay? From -10 to 10, okay? So now if you hit graph, you should be able to see the point of intersection. So let's see. Okay, so there you go is the point of intersection. You can also go to zoom and you can go in. So let's say we want to zoom in. Now you can move the cursor to where the point of intersection is, or near the point of intersection, and press enter. So you can see it better where they intersect, okay? Okay, so now how do we find the point of intersection or solve for the system of equations using the graphing calculator? So the way to do this is go to second trace you should see a function here above that says calc. So you hit that second trace, and then you go down where it says intersect. That's point number 5, okay? So you press enter. Now it's asking you which one is the first curve, and you can actually pick now which curve you want it to be the first one. Okay, so let's say I pick this curve to be the first one. Press enter. And now it's asking you which one is the second curve. So the cursor will automatically jump onto the second curve, okay? So you press enter again. And then it says guess a point. So at this point, you want to go close to the point of intersection with the cursor, okay? And then you press enter again. Okay, so after the calculator did the calculations, you get an output value of x equal to 1 and y equal to 2. And that is actually the point of intersection. That is the solution to the system of equations. So we have 1, 2, and we just solved the problem, okay? Using the graphing calculator. Okay, so in today's lesson, again, we learned 3 methods on solving system of equations algebraically. Let's go over it again really quick. So first we learned how to solve a system of equations by substitution method. Remember that you want to isolate one of the variables in one of the equations and substitute it into the other equation. Then we learned the elimination method, where you want to multiply one of the equations with a non-zero numerical value such that you can eliminate one of the variables by adding or subtracting the equations. And thirdly, we learned how to graph the equations in slope-intercept form and then look for the point of intersection using the intersect calculator function. So let's say you have the following points. A, 4, -1, B is 5, 6, C is 1, 3, and we know that that is a triangle. How would you prove that ABC is an isosceles right triangle? So this is exactly what we're going to discuss in our upcoming lesson. So please don't forget to subscribe so you can get the notification on when this lesson will be ready for you. Other than that, thank you so much for watching and have a wonderful day.